Okay, so starting with number 1. Okay, find the derivative of the following equations. What do you see is involved here for number 1? Product rule, right? Make sure we identify these as 2 distinct functions, f and g. Product rule. Go ahead and try that. F prime g plus fg prime. Okay, hopefully you found number 1 pretty straightforward. 4x cubed becomes 12x squared. We keep the cosine of 2 minus 3x cubed. Sorry. Back to f, and then g prime. Cosine of parentheses becomes negative sine parentheses times negative 6x. Negative 6x represents the derivative of the portion inside the parentheses. So I have 2 distinct terms here. I'm just going to do what I can to clean it up. So within this term, I can rearrange some things, right? Push all the variables together, coefficients, and then have the trig be the end term. So the 4, the negative 1, the negative 6 combines to be positive 24, x to the 4th. You can take a GCF out, but this is good enough. I prefer that you guys do a little bit of cleanup, but technically the right answer is above, but on multiple choice section, this would be the more presentable answer, more likely answer. Okay, number 2, hopefully you guys see a need for quotient rule. There's a second option. What could we do? Could we avoid quotient rule here? Yeah, product, but this cosecant will have to change to what? What's the reciprocal of cosecant? Yeah, so you could also rewrite this as 3 sine minus 3x, and then sine. You do it that way. You can have this as this whole thing as your f function. This is your g, f prime g plus fg prime. Okay. Yeah.
If that happens, what do you think we should do? What's it easier?
Yeah, I don't think there's. I don't have a preference. They both should be doable for you guys. I just went through quotient rule. The product rule may be a little cleaner. Okay, let me know if you have any questions about any of the terms or where those terms are coming from. Okay, any questions with number 2? Everybody good?
Yes, I was just gonna ask, I combined, in front of this sign, I did 30x minus 3.
That's fine. Typically, we like to have everything in factored form. So the more things you can separate, the better, but it's fine. Okay, number 3. How would you approach number 3? Chain rule, right? So you want to rewrite this problem, right? Get that 5 to be clearly outside a set of brackets. Go ahead and identify your outside, inside, and inner problem. Okay, outside's derivative first. Next up, secant derivative. And next up, the inner portion's derivative. Okay, so we got to take derivative of each term. What does 4 pi turn into? Yeah.
4 pi is 0.
Good, right. This is 0, yeah, because pi is just a number. 4 pi is like 12 point something, so that's just going to be 0, just negative 15x squared. do a little bit of cleanup here. I can push all the coefficients, variables together, and then I'll merge the secant, and I'll have the tangent come at the end. Okay, moving on to number 4. Yeah, number 4. Okay, what do you guys see here?
Product rule, and always forget the rule. Always forget this null. So,
Implicit. Yeah, okay. So you know there's dy dx involved there. And then product rule, yeah. Yeah, it's kind of hiding, right? Product rule is kind of hiding, but the y is separate from the secant. We got the product rule there. Okay, y's derivative becomes 1. dy dx pops up. Back to f. G prime secant becomes secant tangents. Okay, what happens to 12? Okay, 0. Negative 3y becomes and then 10x. Okay, you have 4 terms. 2 terms has dy dx attached to it, so add and subtract so they can get the dy dx terms together. Factor dy dx out, and then divide it over. Check number 4. Okay. Number 5. Yeah, let's skip number 5. Let's go to number 6. What do you see for number 6? Chain rule, right? So how would you rewrite this? Mm-hmm. Okay. Outside, inside, inner, chain rule. Okay. I have a number 7 and number 8. It's not on the sheet. I'll go ahead and put that up in a second. Oops. Okay, so here's number 6. Number 6, you got the bracket to the 1/7, outer portion. Tangent is the middle, and the inner is the 1 minus 5x cubed. We take turns with each of the levels here. Outside is derivative first. 1/7 comes down. Subtract 1 from the exponent. 1/7 minus 1 is negative 6/7. That takes care of the outer portion. We move into the next section. Tangent derivative becomes secant squared. And finally, the 1 minus 5x cubed becomes negative 15x squared. Do a little bit of rearranging here. I have a numerator, denominator. I would like to get all this under one fraction. Negative 15x squared, the secant squared stays up top. The 7 goes below, and the tangent goes below as well.
I'll show you. I don't know how to say this. With this also, I wrote it differently than you. I'm pretty sure that's still right. I just brought it, the exponent down.
Yeah, that works. 7th root. Okay. Yeah, that works. Yeah.
All right.
Okay.
Mr. Yang, for
Yes.
this one, would it be okay if we left it as like one straight line, or do you want it to go as a fraction?
Yeah, I still want the negative exponent
Okay.
resolved, so get it under one fraction.
Okay, cool. Thank you.
Okay, so here's number 7. I did not put this on your sheet. Try this one. So you may need to review your unit circle values, right? You can look back on the last page there. I have a unit circle that you can.
You're gonna have an outline.
I'll give you a blank one.
Okay. I just filled out this one.
Okay, this is what I got.
I forgot to simplify and what I get myself.
What'd you get? You got
I got
2 root 3 over 4?
I got y minus 1/4 equals 2 root 3 over 4.
That's fine.
X minus
Let's see if I can come up with a particle motion problem here. All right, number 8. Okay, cotangent of t, find acceleration at power 4. guys get 4?
Yes, I got it. Oh no, I got it. I agreed to.
Let's see.
Oh, I never did chain rule.
Got the chain rule, yeah. Got the chain rule.
Because I think I did the first. Oh yeah, I did negative CSC. It said negative CSC squared.
Oh, to get the velocity function?
Yeah, that's what I got.
Okay, let me go over step by step here. Cotangent of t, derivative cotangent is negative cosecant squared. I'm going to rewrite it if I got to do derivative again, I want to rewrite it so I can clearly see that outside inside portion. So I know before I get to acceleration, I understand there's an outer portion, that bracket squared, and the cosecant I got to deal with. So outside derivative first, -2 bracket to the first power, fill the space with cosecant. Next up, cosecant's derivative, negative cosecant, cotangent. And there's no inner, the inner is just 1, so, or t becomes 1, so I can ignore that. I do a little bit of cleanup here. The -2 times -1 becomes a +2. Merge the two cosecants together, and now I'm ready to involve pi over 4. So pi over 4 gets replaced for all the t's. Cosecant of pi over 4. I know that sine of pi over 4 is √2/2. So cosecant of pi over 4 must be the reciprocal, right? It must be 2/√2. Cotangent is the reciprocal of tangent. I know tangent of pi over 4 is 1. So cotangent of pi over 4 will still remain as 1. Multiply or square this. 4/2, which is 2. 2 times 2 is 4. That's my acceleration. And tomorrow morning, I'll do the same worksheet. So if you know how to do this, you'll have to attend tomorrow morning's help session. Any questions here? So I just included some additional practice worksheets, just if you want additional practice with recalling trig values and unit circle values. I have a worksheet that I pulled from the website, from another website, along with the key. And also I have, I'll provide you a blank unit circle, but I put a key next to it for you to practice and check and make sure you can fill that out. Okay. Let me see if there's anything else I want to share with you. I think on my website, I included a document that I created. I looked at previous quizzes over the years and just try to identify common mistakes. Maybe that could help you avoid them. Let me see if I can find it. Okay, and if you're online, I'll also share this as well. Okay, so let me just go through these here. Okay, so trig derivatives, these are the common things I see. Yeah, understand that, yeah, once you get that exponent, you really you don't want to leave it in that form. I see a lot of students, if they don't put it in a set of brackets, you're going to just completely ignore that outer portion. A lot of students do this. They see this, they want to do 4 cosine, and then start taking the derivative. Number 3, sine cube 3x means that the entire sine function is being raised to a power. Sine 3x cubed is just saying that this is really the same thing as sine of 27x cubed, right? So that 3 is only impacting what's inside sine. This exponent is impacting the entire sine. You guys are pretty good here. Know when to apply implicit, quotient, product rule. Yes, that's the biggest mistake right here. Not letting that shorthand form stay before you do a derivative is going to mess things up. So make sure you always bring that exponent outside. Yeah, those are the big things there. Okay. All right, you guys have your derivative rules memorized? Okay, you guys should be good.
Thank you, Mr.
Mm-hmm.
Thank you.
Yep. See you tomorrow. Mm-hmm.